we now begin our review of Chapter 3 and 4. We begin with a couple of graphing problems. This first equation is in standard form, so I'm going to graph it using the graphing by intercepts method. If I let x be 0, basically we get rid of the 2x. We would divide each side by -3, giving us y is equal to 2. If we let y be 0, we'd say goodbye here to the 3y. We'd see 2x equals -6. So dividing each side by 2 gives us -3. I'll graph this first line down here on the left, a y-intercept of 0, 2, and x-intercept of -3, 0. Gives us these 2 points, and through them we draw our straight line. The second equation, number 2 there, is given to us in slope-intercept form. So we're going to plot the y-intercept of -4 first, and then we're going to see the slope of 1/3, which tells us to rise 1 and run 3 points to the right to get to our second point, and through those 2 points we draw our straight line. Problems 3 and 4 here. 3 is the equation of a vertical line. X equals 2 is a vertical line. Don't plot it just as a dot. Make sure it's that vertical line. The second equation, number 4, can be thought of as y equals -1/1x plus 0. Since no y-intercept is given, we can add on the plus 0, and that negative there can be thought of as -1/1. So this is going to be a graph that goes through the origin and has a slope of -1 going down 1/1. So basically we're going to be cutting straight through the second and fourth quadrants. Recall that the first quadrant's there, second quadrant going counterclockwise, third quadrant here, and fourth quadrant always labeled with Roman numerals going down to the bottom right. We then move on to finding a slope between 2 points. Pretty much you should have the slope formula memorized. M is equal to y subscript 2 minus y subscript 1 over x subscript 2 minus x subscript 1. And the 2 points that we're given here are the x sub 1, y sub 1, x sub 2, y sub 2. And so substituting these numbers in, the y2 minus y1 will be 9 minus a -4. And down in the denominator we're going to have second x minus the first x, 5 minus 3. So our slope is going to be 13/2. Now the next problem asks us to find the slope of the line containing these 2 points. It happens to be the same 2 points that we used up in the problem above, so we know that m is equal to 13/2. We just need to find the equation. So we're going to use the point slope formula, which is another formula that needs to be memorized. Y minus y1 is equal to m times x minus x sub 1. And we need to choose a point to use. I'm going to use the point 3, -4. It's an arbitrary. Either way we're going to get to the same answer. So we're going to have y minus y1, that's y minus the -4, making that a y plus 4, equals the slope of 13/2 times x minus 3. That is the equation of the line in slope or point slope form. If we want to convert it to slope intercept form, which we normally want to do, we're going to begin with distribution. We're going to keep the left side the same. On the right, we're going to have 13/2 x minus 39/2. We're then going to want to subtract 4 on each side. On the right, because we're dealing with fractions, I'm going to need a common denominator there of 2. So rather than subtracting the whole number 4, I'm going to think of that as 8/2. 8/2 is equal to 4. Now we're going to have just the y by itself on the left, and on the right, 13/2 x minus 47/2. If we want to double check this, we can just see that this line contains both of these points. We pretty much already know that it contains 3, -4 because we used that point to find the equation of the line. So I'm going to check by substituting in 5. 13 halves times 5. 13 times 5 is 65. 65 halves minus 47 halves. They've got a common denominator of 2. 65 minus 47 is 18. And we'd have 18 over 2, which is equal to 9. So that tells me that 5, 9 is a point that's on this line, further helping me know that I've got the right answer.